All right, guys, so today we're going to talk about factoring some different polynomials. It'll be a little bit of a review of factoring. We're going to learn some new kind of factoring patterns. Specifically, we're going to do factoring by grouping will be something brand new we'll do towards the end. And at the beginning here, we're going to talk about the difference of squares pattern. So you should have received this worksheet and then a little tiny note sheet that had some of these different formulas on them. So if you want, you can find this on there. I'm going to rewrite it up here. But we have this pattern called the difference of squares. So difference means we're talking about subtraction, and squares, of course, are things that are perfect squares times themselves twice. So if we have two perfect squares, let's call them A and B. So we've got A squared and B squared. Two things that are times themselves twice, so they're perfect squares, and we have a difference between them. Okay, this factoring pattern will always factor as A plus B times A minus B. And so we'll always get this nice factoring pattern back, and these things are called conjugates. And when you multiply or FOIL conjugates together, you always end up, the middle term cancels out. That's why there's no middle term in this kind of quadratic-y thing over here. Okay, but notice the values we're plugging in, A and B, are the values that are times themselves twice. It's kind of like the square root of these two, but we're just going to think about times themselves twice. Okay, so if we look over here, let's identify if these two things are perfect squares. Is n squared a perfect square? Yeah, it's n times n. Is 9 a perfect square? 3 times 3. So those are both perfect squares. We've got a difference between them. That's going to follow my pattern. So let's just identify A. What are we going to plug in for A in our formula? What times itself twice is n squared? N. So we're going to plug in n where we have A in here. And what times itself twice is 9? 3. So for A, we're plugging in n. For B, we're plugging in 3. So we're going to have n plus 3, n minus 3. And there's our pattern. N plus 3 times n minus 3. I apologize for my handwriting on here. But that's it. Those are our factors. You can FOIL them back together if you want. We'll get the same thing as above. So let's try this again. Ooh, a little trickier. Is the number 16 a perfect square? Yeah, it's 4 times 4. Is n squared a perfect square? Yeah, it's n times n. So we can think of this as 4n times itself twice. So this is a perfect square. 25 is 5 squared, so hey, we've got another difference of squares. So what times itself twice would give me 16n squared? We kind of just went over that. It should be 4n. 4n times 4n. What times itself twice gives me 25? Is 5. So plugging in 4n for A and 5 for B, 4n plus 5, 4n minus 5. That's it, 4n plus 5, that's a parenthesis, supposedly, and 4n minus 5. And that's it, those are our factors. And notice our directions today are just to factor. It doesn't say solve. There's no equal signs. We're not finding the roots or zeros. We're just finding the correct factors today. So once we break them down into the smallest factors we can, we're done. Okay, another one. 4 is a perfect square, and so is r squared. And so is 25, so another difference of squares. So what times itself twice is 4r squared? 2r. What times itself twice is 25 is 5. So following our pattern, we get 2r plus 5 times 2r minus 5. Okay, and I would say take a second, try out those other three on the side. If you want, pause the video to try them out. See if you can do those three. Okay, moving on to the next section. We're really just reviewing here, factoring a quadratic. So we've been talking about those kind of x factoring through these. And in fact, the first thing we usually search for is any common factor. And this does not have any greatest common factor. No number we can divide them all by, and they don't all have our same variable of b. Okay, so we're kind of just going to go straight to x factoring here. I need two numbers that multiply to positive 32, but add up to negative 12. So let's see, we could write out our factor list of 32. There's 1 in 32, 2 in 16, 3 doesn't go in there, 4 does though, 8 times. 5 doesn't go in there, 6 doesn't because 3 didn't, 7 doesn't, and then 8 would be a repeat. So I think this is all of them. And if they multiply to positive 32, what does that tell me about our signs? Well, it tells me they're either both positive or both negative. And if they're going to add up to negative 12, they're going to have to both be negative. So if they're both negative, which of these pairs would add up to negative 12? It's our negative 4 and negative 8. So that tells me my two factors are b minus 4 times b minus 8. And that's it. Those are our factors of our quadratic. You could check by foiling them to make sure we get the original, but I think we're okay here. Let's try our next example. Again, I always look for common factors. There's no number that will divide all three, and they don't all three have an x. So because it's a quadratic, we can just go straight to x factoring again. So I need two numbers that multiply to negative 18, but add up to positive 3. So we could come up with our factor pairs that multiply to 18. There's 1 and 18, 2 and 9, 3 and 6, and I think that's it before a repeat. 4 doesn't go in there, 5 doesn't, and 6 would be a repeat. So what does it mean if they multiply to negative 18? Well, that tells me that one has to be positive and one has to be negative. So one's positive, one's negative. And if they're adding up to positive 3, the bigger number has to be positive. So our bigger factor has to be positive, which means our smaller factor has to be negative. So which of these pairs would add up to positive 3? I think our negative 3 and positive 6. So x plus 6 times x minus 3. So just a little review of x factoring in that section. Okay, in our next section here, next we're going to look to factor out the GCF, greatest common factor. And so we were looking for it in the previous problems, even though we didn't see any. And here, even though our numbers, there's no number I can divide out of all terms, they do all have an x. And if I divide an x out of both terms, imagine dividing each by x, we'd be left with 1x. And over here, those x's would cancel, and we'd be left with minus 9. And that's it. Factoring out an x gives us x times x minus 9. Those are my factors. It's actually as easy as that. So you could try number 12 if you wanted to pause the video. It should only take you a couple seconds. But let's move on to our next one. This time, what are all terms divisible by? Now, they don't all have a v, but they are all divisible by 5. So we're going to factor out a 5 first. So imagine dividing these all by 5. We're going to write our results inside the parentheses. Dividing by 5 here, we get 1v squared, negative 9v, and 19 divided by 5 is 18. Okay, but notice inside of here we still have a quadratic, and it might factor further. Are there factors of 18 that add up to 9? 6 and 3, right, would add up to 9. So I think it is factorable. So maybe we're going to come off to the side here and do an x factor and try to break down this remaining quadratic. We need two numbers that multiply to 18, add up to negative 9. Well, they have to be the same signs, either both positive or both negative. And because they're adding up to negative 9, I think they both have to be negative. And our factors of 18 are 1 and 18, 2 and 9, 3 and 6, and that's it. So if they're both negative, the pair that adds up to negative 9 are negative 3 and negative 6. So this 5 still stays on the outside. It's still one of my original factors. But we can break down that quadratic as v minus 3 and v minus 6. And so completely factored out, we get this. And so yes, on a test, if it says factor completely, and you have a quadratic, you should try to factor it if you can. Okay, next it says factor out the greatest common factor and factor the quadratic. Well here, let's see, all my terms are actually divisible by 6, and they all have an n. So we're going to take out a 6 and an n, sorry about that, a 6 and an n from all terms. Okay, so put up some parentheses here. Divide this by 6n. We get 1n squared. Divide that by 6n, we get negative 2n. If you divide this one by 6n, it's a little tougher, but I believe that's minus 24, and the n's cancel. Then it says, and factor the quadratic, so it's even to give me the hint that I should probably be able to factor the remaining quadratic. So let's do an x factor. I need two numbers that multiply to negative 24, add up to negative 2. They have to be opposite signs to multiply to negative 24. And our bigger number is going to have to be negative to add up to negative 2. So the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. And we said the bigger number has to be negative. So you can imagine the bigger numbers here all being negative. So the pair that adds up to negative 2 is at the bottom, positive 4 and negative 6. That's supposed to be a 4. There we go. Okay, so we still have the 6n on the outside, but we broke this quadratic up into two smaller factors, n plus 4 and n minus 6. And that's it. Those are our two factors for this section. Okay, our next one, factoring when a is not 1. So we call this like our advanced x factor, or the bottoms up method. So again, the first thing I would look for is any greatest common factors. Because 2 and 17 are both prime, definitely not a number we could divide everything by. An x squared, we don't all have an x. Okay, so no greatest common factor. And if it's a quadratic where this a value or this leading coefficient is not 1, this is where we're going to kind of do that cheating advanced x factor or bottoms up method. So we can multiply our 2 over. Remember, we're going to like temporarily hide it. And we're going to create a quadratic that is not equivalent to the original, but it's going to help me find the correct factors. Okay, so this new quadratic, we're going to x factor. I need two numbers that multiply to negative 60 and add up to negative 17. Okay, so 60 does have a lot of factors. So this could be a long list here. So 1 and 60. Wow, that looks pretty bad. 1 and 60, 2 and 30, 3 and 20, 4 even goes in there 15 times, 5 goes in there 12 times, 6 goes in 10 times, and I think that's actually it, thank goodness. Okay, well if they multiply to negative 60, they have to be opposite signs, so one's positive, one's negative, and to add up to negative 17, the bigger number needs to be negative. So which pair would give me negative 17? I think that's right here. So we get positive 3 and negative 20. But if you remember, when we did this x factor, we have to divide them both by that, oops, not 5, apologies, by that 2 that we multiplied over. So we multiplied over this 2, we kind of hit it. This is where we end up undoing that part. So we're going to write our factors as x plus 3 halves and x minus 20 halves. And if one of them reduces to a whole number, which this should give me x minus 10, then that's perfect. That's one of my correct factors of the original. And remember, the reason they call this bottoms up is if my remaining fraction does not reduce any further, but still has a bottom or denominator, We can bring it up in front of x, and our other remaining factor is actually 2x plus 3. And these two do multiply back to the original. You can double check, even if just doing the first and the first, or first and last. 2x times x is 2x squared. 3 and negative 10 is negative 30. And you could finish foiling to check the middle term, but we did get the correct factors. Okay, so let's try this one more time. No greatest common factor again this time. So we're going to have to do this bottoms up kind of cheat. So we get m squared plus 7m. 5 times negative 24 is negative 120. So man, 120, if 60 had a lot of factors, 120 is going to have even more. So unfortunately, it's going to be a big factor list here. But let's see, I need two numbers that multiply to negative 120 and add up to positive 7. I'm good at making my x the right size. All right, so 120 is going to have some factors. You got 1 and 120, 2 and 60, 3 and 40, 4 and 30. 5 definitely goes in there. What is that? 14 times. 6 goes in there 20 times. 7 doesn't. 8 does, though, 20 times. Sorry, 15 times, not 20. 9 goes in, does not go in there. 10 does, 12 times. And 11 doesn't, and 12 is a repeat. But man, that is a gigantic list. All right, so I know my numbers have to have opposite signs to multiply to negative 120. And they need to add up to positive 7, which tells me the bigger number is positive. Therefore, the smaller number must be our negative 1. Okay, so we're looking for the pair that adds up to positive 7. I think that's down here. So we get negative 8, positive 15. Don't forget we're using a cheated quadratic here, so I have to come back and divide them by this a value. We've got to divide them by 5. So my two factors are m plus 15 fifths and m minus 8 fifths. Oh goodness, there we go. Okay, this one will reduce to m plus 3. And this one does have a remaining bottom. We cannot reduce our fraction, so we're going to bring the bottom up in front of m. So we get 5m minus 8. And again, you could double check by foiling these out to make sure it does equal the original. You can even quickly check the first and first. M and 5m give me 5m squared. 3 and negative 8 give me the correct negative 24. So a nice quick check, even if you don't really check the middle term. Okay, let's get into the new part. So other than the difference of squares we did at the beginning, this is brand new. Factoring by grouping. So before we actually do the factoring, I'm going to show you what happens when we FOIL two things together. It's twice now. So let's actually FOIL this together real quick. It's actually pretty fast because we don't even get like terms, which is kind of cool. 2x squared times x is 2x cubed. 2x squared times negative 4 is negative 8x squared. Okay, done distributing that. 5 times x is positive 5x. And 5 times negative 4 is negative 20. And notice none of those are even like terms. So this is it. This would be my final answer. Okay. The one thing I'm going to point out here, though, is that, oops, we can leave that, is that what we just did is we took 2x squared times x and times negative 4. So this is actually equivalent to writing this. 2x squared times x minus 4, right? We distributed the 2x to the x and the negative 4, just like we would here. Then we took the positive 5, and we distributed it as well to x and minus 4. Okay. So what we just did is equivalent to this, and if I distributed here, I'd get these first two terms. If I distributed here, we'd get the second two terms, and we would just add them together. So this is equivalent to what we did in the beginning. And I know it looks a little strange. The reason I'm showing you this is because in factoring by grouping, we're going to get to this step. And we need to know that it's telling me that x minus 4, in our parentheses here, okay, is one of our factors, and that our other factor is actually out here, the 2x plus 5. Okay, so when we do factoring by grouping, we're going to kind of get to this stage. So here's how we do it. We'll do it with this problem. We'll get this as our answer, but let's try it on here really quick. Okay, so what we're going to do is we're going to group these up. And I always like to do first two, last two. You have to group them in such a way that there's some sort of common factor you could take out, but first two, last two always works. So let's just do first two, last two. Okay, so we're going to look for a common factor in just these two terms. They're both divisible by 2, so we can take a 2 out. And I can take as many as x squared from both. So we're going to take a 2 and an x squared out. And we're going to factor it from just these two terms. So when I divide a 2x squared out of here, this term will leave me with an x. And when I take this and divide it by 2x squared, I'm left with negative 4. Okay. From my other pair, what do I have as a common factor I can take out here? Well, they're both divisible by 5, so let's take out a positive 5. And when I divide that out, 5x divided by 5 is 1x. Negative 20 divided by 5 is negative 4. And again, if you notice, one of my factors is the matching set of parentheses. And I have to get the parentheses to match for this method to work. Okay, and they did match, so x minus 4 is one of my factors. My pen will work here again. There we go. And our other factor is actually out here. It's the multipliers on the outside. 2x squared plus 5 is our other factor. And so there's my answer. If I can get these parentheses to match after we take out common factors, then that parentheses is one of my factors, and the numbers outside are my other factor. Okay, so let's try a couple quick examples. Okay, and this one. Well, we got some big numbers here, but let's give it a shot. Okay, we're going to take out, we've got these 4 terms. We're going to try our factoring by grouping. This is really the only method we have to deal with when we have 4 terms. Okay, so other than taking out maybe a greatest common factor, which it almost looks like there should be, but 21's only got 7 and 3. Those are divisible by 3, but that's not. That's divisible by 7, but those aren't. And they don't all have a b, so there actually is no greatest common factor. But when we have 4 terms, one of the things we always want to try is factoring by grouping. So let's try this out. We're going to again do first 2 and last 2. Okay, so let's work with the ones in the front. What can we divide both 28 and 21 by? 7. And this has a b cubed and b squared, so we can take as many as b squared from both. So when I divide by 7, we get 4, and b cubed over b squared is b, 4b. 21 divided by 7 is positive 3, and then our b squareds cancel out. So this is what I'm left over with, 4b plus 3. Okay, now over here I need what's left in the parentheses to match. So let's keep that in mind, because they're both divisible by either 6 or negative 6. And if I want this to match positive 4b plus 3, I think we actually need to take out a negative 6. So if I divide by negative 6, negative 24b divided by negative 6 is positive 4b. And negative 18 divided by negative 6 is positive 3. And so here in my parentheses, they did match. That is one of my correct factors. 4b plus 3 is one of my factors. And remember that my other factor was on the outside here. So my other factor is the 7b squared minus 6. And that's it. Those are our 2 factors we could multiply to get that polynomial. Okay, let's try one last one down here. Okay, we've got 4 terms. There is no greatest common factor, so we'll pair them up again, first 2, last 2. I think I've got white selected. Hang on. So let's do first two, the last two. It doesn't really matter which color goes with what. All right, in my first two, there's no number I can divide out of there, but I can take an x squared out of both. If I divide each by x squared, I get 1x minus 5. Now keep in mind, I need to get what's in the parentheses to match. And actually, it looks like there's no greatest common factor in this second pair. But that means we can always try to divide out either 1 or -1. And I think to get it to match here, we're going to need to take out -1. And if I divide each by -1, I get positive x and -5. And we were able to get our parentheses to match. So that means one of my factors is x minus 5. And my other factor is the x squared minus 1. Ooh, wait a second. We're almost done here. Except this pattern we saw in the very beginning of the lesson. X squared's a perfect square, 1's a perfect square, and we got subtraction. This is that difference of squares. So this factor we can break down further. What times itself twice is x squared? X. What times itself twice is 1? 1. So that difference of pattern, or difference of squares pattern, will be x plus 1 times x minus 1. And then we'll just drop down our x minus 5. And so we're actually able to break this down really, really far. So that's pretty awesome. All right, there's a little bit of mixed review in here. I'm going to skip it for the video just to save some time. We're running a little bit long. The answer key should be on Google Classroom to check these out. And we did do examples of everything like this already in the previous notes. Okay, if you need more help, check the answer key online, check with people in your group, send me an email, or rewatch the video, go through those examples again. All right, good luck.